matrix like C so that CA equals identity matrix, AC equals identity matrix. A question, is the inverse of a matrix unique?
What?
Yes, doctor, is the inverse because it's invertible.
So your friend says that inverse of a matrix is unique. This means a matrix has at most one inverse matrix. It is not possible that a matrix has more than one inverse.
It's
The
one
answer,
inverse to the matrix.
sorry,
It's one inverse to the original matrix.
yes. So
Yes,
you
because
say that a
because we have seen
matrix
that.
has at most one inverse. So if a matrix is invertible, then its inverse is unique, right? This is what you mean.
Yes, because there is one solution.
Yes, doctor, it's unique because it's one inverse.
Your reason is not correct, but your answer is correct.
So it's not correct because it has one solution.
It has one
One un-
inverse
because one is
because why? What's the reason? Because of this. Assume that it has another inverse like B. So consider matrix A whose inverse is C. So we have CA equals I and AC equals I. Now assume that A has another inverse like B. We show that B is the same as C. So B and C are the same. So A has a unique inverse, not two different inverses. So B is inverse. So we have BA equals I and AB also equals I. More than CA being equal to I and AC being equal to I, we have BA equals I and AB equals I, right? Okay, we want to show that B and C are the same. So we have B. B equals BI, right? Because I is identity matrix. Instead of I, you can write AC because of this.
I will.
Because C is inverse of A, so AC is I. So you write B as BI and then I as AC. So you have BAC. What is BA? BA equals I. So instead of BA, you can put I. So you will have IC and IC equals C. So you get this conclusion that B equals C. So they are the same. B and C are the same. So matrix A has only one inverse. It doesn't have two different inverses. It has only one inverse. B and C are exactly the same matrix. Right? Is it
Right.
clear?
Yes, doctor, clear.
Okay, great.
Yes, doctor.
Yes, doctor.
Okay, so we call this a unique inverse as A minus 1. So A minus 1 is the unique inverse of matrix A. So we have these properties. A minus 1 times A gives identity matrix, and A times A minus 1 gives identity matrix, right? A minus 1, A gives identity matrix, and A minus 1 gives identity matrix, right? So, for example, consider a 2 times 2 matrix, A, B, C, D. It is invertible if AD minus BC is non-zero, and in this case, the inverse is obtained by the following relation. A minus 1 equals 1 over AD minus BC times E minus B minus CA. Actually, you exchange the entries in the main diagonal and you make the other entries negation, right? So in the special case of 2 times 2 matrices, the inverse can be obtained from this equation. A minus 1 equals 1 over AD minus BC times E minus B minus CA. How can you verify that A minus 1 is the
Awesome.
correct inverse of matrix A? So this is a claim, right? So someone should verify that this is correct. This formula given for A minus 1 is correct. How can we verify this?
if الAD
Didn't equal.
minus BC not equal 0.
If A is equal AD minus BC, it's invertible.
So,
Using this formula.
so the question is, we have A and someone has claimed that A minus 1 is obtained by this formula. How to verify if he or she is right or not?
If A not equal to 0.
No. What was the condition for inverse? In the previous slide I mentioned.
If the inverse in odd not in even, right?
No.
Doctor, if AD minus BC equals 0 is not invertible.
Original.
No. We should check that.
آقای دکتر میشه
A
If,
inverse
Doctor, if
it's
A
equal
of
A inverse
times A inverse so in identify.
if it's
We should
identical.
check that
Uh,
A times A
if
minus
multiply the matrix with the inverse matrix equal 1.
equals identity matrix.
Identity matrix.
Equals identity.
Yes, exactly. So if we want to verify if this theorem is correct or not, we should verify whether multiplication of A and A minus 1 gives identity matrix. So you can do it by yourself if you are really curious about the correctness of this theorem. Please compute A times A minus 1 and see what's the result. The result will be I. A and A minus 1 defined in this way. The multiplication will yield identity matrix. So inverse of A is A minus 1 and inverse of A minus 1 is A, right? So A and A minus 1 are inverses of each other. Inverse of A is A minus 1, inverse of A minus 1 is A. Okay. Okay, so now let's move to the next point. Suppose that we have an invertible matrix like A. And A is the coefficient matrix of a system of linear equations. So we have a system of linear equations like this, Ax equals B. Then this system, if A is invertible, for every B, for any arbitrary B, it has a unique solution, and its unique solution is something like this. X equals A minus 1 B.
Sorry, doctor. That means we multiply the matrix B by the identity
No, by
matrix.
the no.
By the inverse matrix. So X equals A minus 1 B. We multiply A minus 1 and B to get X. So let me say this again. We have a system of linear equations like this, Ax equals B. If A is invertible matrix, then for every B, for any B, for every B, Ax equals B has a unique solution. And this unique solution is obtained by this. X equals A minus 1 B. Why is this correct? Can someone explain?
Because
Then we have a system of linear equations like X equals B and A is invertible. Then for every B, we have a unique solution, and this unique solution is in this way. X equals A minus 1 B.
excuse me, doctor. If we have identity A multiply AX, it will be if we consider to delete or to remove A by A, then we'll have A plus minus 1B. It's my idea, it's clear?
So, a short and correct answer is
I
something.
think so.
Yes. So it's AX A or IA multiplied by AX.
So consider this, X equals B. And A is
It's
invertible.
mean X equal B
identity A.
divided A.
Identity A because the inverse it's identity, right? Multiply
What
by
is ident-
AX. I mean
what is
identity A multiply AX equal to A multiply by B. Then we will have the X, it will be A inverse.
Because it substituted from X by using identity to extract B from X. Because the B is a result from A by X.
Okay. So,
invert A, transfer A.
Doctor, it has a unique solution because the identity, all the main diagonal of it, it's equal to 1. So there is no free variable. Therefore, it has a unique solution for B.
okay. Let's see in this way. So we have X equals B, right? We have X
Then
equals
X, then X it will be A inverse B.
So we have X equals B, and we know that A is invertible. So we can multiply both sides of this
By A.
equation by A
by
minus 1.
inverse.
Yes, by A minus 1.
So we will have A minus 1,
minus 1
then A
after
X,
As identity is removed.
X
AX
equal B
equals
equal to A
A
minus
And B.
1
minus 1,
B.
and then B.
So
So
this A
we
minus 1 minus
we
1
will
to
have this because we have X equals B, and we know that A minus 1 exists. So we can multiply both sides by A minus 1. So A minus 1A equals identity. So it is,
Identity.
it is eliminated, and we will have X
X equal
equals A
A
minus
minus 1 B.
1B. Right? This is the unique solution of Ax equals B. Then A is invertible. So over here, it has checked if X equals B has another solution like U. Then U should be equal to A minus 1B. So A minus 1B is will be the unique solution. So suppose that U is a solution. AU equals B. Then we multiply both sides by A minus 1. So we will have
نفس الشيء.
A minus 1 AU equals A minus 1B, and A minus 1 A equals I, which is removed, eliminated, and we will have U equals A minus 1B. So any other solution like U will eventually be equal to A minus 1B. Right? So A minus 1B is the unique solution. So let me repeat this again. If we have a system like X equals B and A is invertible, then for every B, it has a unique solution which is equal to A minus 1B. Right? Is this clear to you?
Yes,
Yes,
doctor.
Doctor.
Okay.
Yes, doctor.
Now let's move to the next point. Inverse of
Yes,
inverse,
doctor.
inverse of inverse of a matrix A equals A. So A minus 1 minus 1
إيه يصير واحد.
is A. The second point is that AB minus 1 equals B minus 1, A minus 1. AB minus 1 equals B minus 1, A minus 1. This means when you bring inverse inside matrix multiplication, the order of matrices becomes reverse. So AB minus 1 becomes B minus 1, A minus 1. The third property says that you can exchange transpose and inverse. So A transpose minus 1 equals A minus 1 transpose. So if you have a matrix and you want to first take inverse and then transpose, you can equivalently take first transpose and then inverse. You can exchange transpose and inverse, right? Please let me repeat these 3 points. So the first point is A minus 1 is A. Inverse of A is A. If you apply 2 inverses, it will be A. If you apply 3 inverses, it will be A minus 1. If you apply 8 inverses, it will be A. If you apply
Even. Just even.
even, yes, if you apply an even number of inverses, it will be the original matrix, A. If you apply an odd number of inverses, it will be A minus 1. Alright, this is one point. Second point. AB minus 1 equals B minus 1, A minus 1. Alright, AB minus 1 equals B minus 1, A minus 1. AB minus 1 equals B minus 1, A minus 1. And the third point is that if you can exchange the place of transpose and minus 1 if they are after each other. If you have A transpose, then minus 1, you can write it as A minus 1 and then transpose. If the key point over here is that minus 1 and transpose should be after each other. So you shouldn't have something else here, for example. For example, you shouldn't have A transpose, then some other term, then minus 1. No, it is not valid. If minus 1 and transpose are immediately after each other, you can exchange them. Instead of A transpose minus 1, you can write A minus 1 transpose, and vice versa. Okay? Are these points clear to you?
حجين الغالي. اي
That's clear.
كان نطاف من يومكم.
Yes, doctor.
اي طاب بس
Great,
شغلوك
great.
ما شاء الله ما شاء الله.
Okay. Let's move to another
elementary.
concept or notion. Now we want to see how to compute inverse of a matrix. In the case of 2 times 2 matrix, it is easy. We already saw the formula. But in the case of larger matrices, it is a bit more challenging. We want to find a method or algorithm that computes inverse of any square n times n matrix. This algorithm is based on some notion called elementary matrix. Elementary matrix. ماتریس ابتدایی یا اولیه. You know what is اولیه, right? Elementary. It is called ماتریس ابتدایی or
مقدماتي
اولیه
مقدماتي.
مقدماتی. بله. Okay. So what is a elementary matrix? Elementary matrix is a matrix which is obtained by applying a single row operation on the identity matrix. So elementary matrix is a matrix obtained by applying a single row operation on an identity matrix. What is a row operation? What are 3 types of row operations?
It's multiply and minus summations, these things.
So, what are these things?
Replacement also. We can this we took at the beginning to find the reduced echelon form.
Exactly.
Hmm.
So, we had 3 types of row operations. Right? If you remember, we had row replacement. What was row replacement?
Changing row by row to get what we want.
No, in row replacement, you replace a row
Row by row.
by the sum of that row and a multiplication of another row, right? So in row
Yes, correct.
replacement, you replace row by the sum of that row
Row.
and a multiplication of another row. This is called row replacement. The other operation was row interchange. What was row interchange?
Row by row. Interchange row by row.
So yes, you exchange the position of two rows, right? It's called row
Doctor,
interchange.
we interchange between two rows if we did not have a pivot position or leading entry
In general,
in general.
interchange, exchanging the position of two rows is called row interchange. It was a
Yes,
second row operation.
yes,
So the
doctor.
third
Especially when the leading entry
operation,
is not it's zero. We interchange.
the third operation is row scaling. Row scaling. What is row scaling?
Row scaling multiply the row by real number by any real
By
number.
scale number.
Scaling
Yes.
Multiply row, doctor, by scalar.
multiply by row.
Yes, you multiply each element of a row by a non-zero value, by
Yes.
a non-zero real value, right? Or divide each entry by a non-zero real value. So we have three types of row operations. An elementary matrix is obtained by applying one row operation on the identity matrix. So let's see an example. Consider this matrix E1. Is it elementary or not?
Elementary. Mm-hmm.
Yes,
Yes,
it's
yes.
elementary
No.
Why is it elementary?
because maybe here we can find maybe there is a -4 and we can change it to the identity by making -4 is 0. So it's elementary.
It is elementary because it is obtained by applying a row operation on the identity matrix. So
Yes,
what is
exactly.
that operation? What is that row operation?
We can multiply
Well,
the first row by 4, then add it with the last one.
With the third one.
So that means our row 3 it's equal to 3 row 1 plus row 3. So we'll get the identity matrix.
Row
We
1
don't
multiply by 4
So the
and
0,
sum
0, 1.
row 3.
Yes. That's right.
This is the result here.
So this is the identity matrix, right? Right? I
Yes,
wrote
right.
here.
Yes.
So E1 is obtained from this identity matrix by row replacement. So it is not converted into identity matrix. It is obtained from identity matrix. E1 is obtained from identity matrix by applying a row replacement. In this row replacement, row 3, this row is replaced by sum of this row and -4 times of row 1. right? If
Yes,
you
doctor.
apply this row replacement on identity matrix, E1 is obtained. E1 is obtained by applying row replacement on identity matrix. What row replacement? Row 3 is replaced by the sum of row 3 and minus 4 times of row 1. Right? Do you agree?
Yes,
Yes,
doctor.
clear.
Clear.
Yes, Doctor. Yes.
Okay.
Sorry,
Yes,
doctor,
doctor,
please
yes.
repeat.
Sorry?
Doctor, can you repeat, please?
So E1 obtained by row replacement in I. What row replacement? Row 3 in I is replaced by the sum of row 3 and minus 4 times of row 1. So you have matrix I. You apply this operation on this. You replace row 3 in I by sum of row 3 and minus 4 times of row 1. The result becomes E1. Right?
Yes.
Right?
Yes, doctor.
Okay.
Okay,
And
doctor.
now consider E2. E2. Is E2 an elementary matrix?
No,
Interchange.
we should
Row
change.
2. Interchange.
Row 2 with row 1.
Yes. So it is elementary matrix,
Interchange
right?
auto one.
Yes, if we change the rows.
Yes. First say yes or no, then yes. Yes. So it is elementary matrix. And it is
Yes.
obtained by interchanging row 1 and row 2. So if you consider the identity matrix and in this identity matrix you interchange first row and second row, E2 is obtained. So E2 is an elementary matrix. Now consider E3. Is E3 an elementary matrix?
Yes, elementary.
Why?
It's non-zero. The
Also because it's
If
obtained from the identity
if
obtained
we
matrix.
if we multiply row 1 by minus 5 and
No,
sum
just
row
just
3.
divided by 5.
Yes, because in identity matrix, if we multiply the third row by 5, E3 is obtained, right?
Yes, right.
yes, doctor.
Okay, great. So if multiply, so E1, E2, and E3 are elementary matrices. Now consider A, matrix A, which is not elementary matrix. It is A, B, C, D, E, F, G, H, I, as you see. Compute E1, E1A, compute E1A. Compute it, compute E1A. I'll give you 30 seconds and then you compute E1A. And let me know what is E1A in 30 seconds.
وانا صوت يمكم الدكتور دا يسولف لا شو ماك صوت يمي.
لا يقول 30 ثانية حلو
لا ما
السؤال.
كان 30 ثانية على مود نجاوب.
هو شو يريد
شنو
المصفوفة أي لو المصفوفة يا هي يعني أي يريد؟
E1 A
اي
هاي
1
جوا الكمبيوت
يعني
E1 A.
صار عليها عمليات يمكن
Did you
الذي
compute or not?
Yes,
Did you
doctor.
compute E1A? So
Yeah,
what is
we
E1A?
A1A, it's the first row, it's A, B, C. The second one, D, E, F. The third row, it will be G minus
G minus
4A,
4A.
H minus 4B, I minus
I
4G.
minus 4C.
Yes, it is something like this. So,
Yeah, exactly like this.
what is E1A? So, what is the relationship between A and E1A? A is A, B, C, D, E, F, G, H, I. And E1A is something like this. So, what is the relationship between E1A and A?
Replacement operation to interchange between row 1 and 3 to remove 4 to give identity matrix.
Exactly. So, E1A is obtained from A by row replacement, in which third row is replaced by the sum of third row and minus 4 times of first row. This is exactly what is done in E1. So, instead of applying a row replacement on A, you can apply that operation on identity matrix and build E1, then write the change matrix as E1A, right? So you have matrix A. You want to apply a row replacement on A. You want to replace row 3 with sum of row 3 and minus 4 times of row 1, right? You want to apply this row operation on A. Instead of doing so, you can apply the same operation on I and build E1. Then, instead of applying that operation on A, you can compute E1A. They are the same, right? You don't apply a row operation on A. You apply on I, you generate E1, and then you compute E1A, right? They are the same. So,
So, doctor,
E1,
the invertible matrix A, it will be equivalent to identity matrix, right?
what is equivalent to identity matrix?
So if then that's mean you meant here uh, if we can find the inverse of A, then we can find the identity matrix, right?
We are not talking about inverse now. So we just want to say that we have a matrix A, right? And
Yes.
we want to apply an operation on it. We want to apply a row operation on A, right? We want to replace third row of A by the sum of A and minus 4 times of first row. We want to apply this row operation on A. Instead of this, we can apply the same operation on I and generate E1 and then compute E1A. E1A exactly will give you the same row operation. In E1A, you see the third row is replaced by the sum of third row and minus 4 times of the first row. This is the point here, right?
We got your point.
Okay, and also this holds for row interchange. So what is E2A? It is something like this. So in E2A, you see that
Exchange.
yes,
Row 1, row
exactly.
2.
So the place or the position of first row and second row are interchanged, right?
Yes, Doctor.
So instead of applying this operation directly on A, you can apply this operation, the same operation on I and generate E2.
Exchange on 0.
And then multiply E2 by A. E2 by A. It gives you exactly the matrix obtained by applying the row interchange on A. So you want to interchange the place of first row and second row, right? This is your objective. This is your goal. You want to interchange the place of first row and second row in A. One option is to directly apply this operation on A. The other option is to apply this operation on I and generate E2, then multiply E2 by A. So E2 times A is a matrix which is obtained from row interchange in A, right? Do you agree?
Right,
Yes,
Doctor.
Doctor, we agree.
Okay, and also for row scaling, something like this. So
Multiply the third row by 5.
exactly. So you have A, right? And you want to multiply the third row by 5. Instead of directly doing this with A, you can apply this operation on I and obtain E3. E3.
بس خلي احكي.
سؤال مايك
Then
المايك.
you can compute E3A, which gives you the matrix obtained from applying row scaling on A. So it doesn't matter if you apply the operation, the row operation on A or you apply it on an identity matrix, you get a elementary matrix and multiply elementary matrix with A. They are the same. Do you see the point?
ان شاء الله.
Yes, Doctor.
Okay. So let me repeat it again because it's important. So,
No, continue, Doctor. No.
so these two are the same. Either you apply a row operation on A, this is one way, this is one option, and the other way, the other option is that you apply exactly the same operation on I, you obtain an elementary matrix like E1 or E2 or E3, and then multiply that elementary matrix with A. These two are the same. So E1A, multiplication of E1 and A is exactly the same as applying row replacement operation on A. E2A is exactly the same as applying row interchange on A, and E3A is exactly the same as applying row scaling on A. So these are the same. So sometimes instead of applying a row operation on a matrix, we consider applying the same row operation on the identity matrix and build a elementary matrix and multiply that elementary matrix with A, with our matrix. They are the same. Okay? Okay. Okay. So we can stop here. If you have any question, you can ask.
Thank you, Doctor.
Okay,
Thank you.
so these elements, please keep,
Thank you, Doctor.
please keep,
Thank you, Doctor.
please keep these definitions of elementary matrix in your mind. Tomorrow we will take advantage of them to present our method for computing inverse of a matrix. All right, so these are very important. Elementary matrices are very important. Please keep the definitions in your mind. Tomorrow we will talk about how to use them to compute inverse of a matrix. Okay, so if you have any question, please ask. Any question or comment? Okay, it seems there is no question. Thank you and bye.
Thank you so much, Doctor.
Thank you, Doctor.
Thank you.
You're welcome.
Thank you,
Thank you,
Doctor.
Doctor.